Our next topic is going to be on hydrates. Hydrates are generally not covered in your on your nomenclature guide. However, that whenever adding them, it really doesn't add too much complexity. Hydrates are basically cases where if you have a particular substance, when you have sort of a compound, that it's when it's in a dry form, is that oftentimes is that compounds will form crystals. And when they form crystals, it's not uncommon to have water molecules which are not attached to the molecule, but they do sort of sit inside the crystal. And so if you imagine a case of like a crystal that makes sort of like a pentagon shape, the way the atoms join together, is that you could imagine there might be a water molecule that sits in the middle. And so, you've got this case where, you got some crystallized thing, you got molecules on each of the vertices of this pentagon right here, and then somewhere sort of right in the middle here is our little water molecule. It sort of sits right there. And so that's sort of how that might work. So you can have sort of in hydrates, you have water. It's not attached to the molecule, but it's in with it. It sort of travels along with it. It's sort of, in a sense, sort of like a parasite. Not really, though. It doesn't really live off of the other molecules, but it's always with them in cases of hydrates. And that's why they call them hydrates. The key is hydra, water, right there. And so they contain water and other compound. The way you write out the formula for a hydrate is you write out the formula first. That's like our XXYY right here. And then you do a dot, and then you put NH2O, where N is the number of water molecules for every one molecule of the original compound. And so an example for the way this might work is that let's suppose that what we had here was we had a hydrate of table salt. This doesn't actually happen very often, but if you did, this is basically how it would work. We would say that we had NaCl, that's the formula of the compound, and then if we said that that there were 3 water molecules for every NaCl, we'd do a dot out after it, and then we would say 3H2O. Just like that. And so what this would show is this means that I have water that is basically mixed in, that is inside crystally, inside my salt here, my NaCl, my sodium chloride, and that for every 1 sodium chloride molecule, there are 3 water molecules. Now, note whenever you have hydrates are generally dry. The water is inside the crystal, and so it doesn't feel wet. It is possible to pull one out. We will find that soon enough. In fact, actually, that's the lab that we'll be doing here in just a little bit. But for what we've got right here is that this is sort of how this sets up, is that we have NaCl3H2O. The way you would pronounce this is you would first name the part that's down here, so NaCl. That's sodium chloride. And so you'd say sodium chloride, so that's our first name, compound name, and then you'd follow it by the prefix. The prefix here is 3. Remember that before we talked about the numeric prefixes, and the numeric prefix for 3 is tri. And so you would call this sodium chloride trihydrate. And so that's basically the way we set this up. So sodium chloride trihydrate would be NaCl.3H2O. That's how you'd pronounce it out. And so this is the way that basically hydrates work, is that you can either go back and forth, you're given a name for one, you can figure out the formula, or you're given a formula, you can figure out the name. And